I'm Anil Kumar, and here is a test question for you. This will help you review the concepts which you've learned in these set of videos. So the question here is to write down four different equations. I would like you to write four different equations for the graph. Let me write function here, okay? For the function that represents the given graph. So that is your question. Now how to do that? You can pause the video, write down four different equations, and then look into my suggestion. So as we discussed earlier, to write down equation of a sinusoidal function from the graph, we need to find what is the maximum value, what is the minimum value, so that we can read from the graph itself. So the maximum value here is positive 1, minimum is minus 3. Knowing maximum minimum, we can find the axis. Axis is average of these two, so we'll add them and then divide by 2. So when you add and divide by 2, minus, let me write this as this, and then we get minus 2 over 2, which is 1. As soon as you find the value of axis, sketch it. So minus 1, I would like to sketch the axis, which is y equals to minus 1. Now amplitude you could easily find by seeing the difference between axis and the minus 1. Difference between axis and the maximum value, right? So maximum minus axis. So that is 1 minus minus 1, and that is equals to 2. Alternate method, you know, is you can find difference between maximum and minimum, divide by 2. You could do that also, right? So this is your amplitude. So it is difference between the maximum value, right? So that is your maximum, and the axis. So easy. Now once you do this, you are ready to give amplitude and also the vertical translation. So you have already got the vertical parts of your equation. When we say equation, we are trying to say equation in the form of, let me write that also, y equals to a sine k x minus phase shift plus d, right? Or q you may write. Now we are looking for four different equations, so we could work on sinusoidal function, and we could also work on y equals to a cos k times x minus p plus d, right? Some books will write c and some books will write q. I've just mixed up both. Okay. Now to find the time period, which is the horizontal distance between two maximums or two minimums, well, here let's read from here. So let's find the time period from the graph. So time period, as you can read from here, is 2. 2.5 minus 0.5. So the time period is 2.5 minus 0.5 is 2. Time period is related with k. K equals to 2 pi by t, right? So when you divide 2 pi by 2, let me write here 2 pi by 2, you get k equals to pi. So from here, what we know is that a is equals to 2 for us, k is equals to pi. This value is same for both sine or cosine, right? So that doesn't really change. What really changes is the phase shift. Since you know that sine and cosine are waves which are translated quarter of the cycle, right? Left or right, right? So that is what it is. So phase shift p will change in these equations, but a, k and d value will remain same. Axis we calculated as minus 1. So these three values will remain same. Now let's find out the phase shift. Phase shift will give us different equations, right? So first, let me consider, since we have to give four different equations, we'll find phase shift of the sine wave. Sine wave actually starts on the axis rising up. So that is how we see from the axis rising up. Clearly you can see here it rises from position p equals to 1, right? So this position is 1 for us. That means the sine wave has moved 1 unit to the right. So p is equals to 1. If I write p equals to 1, I can write down my first equation, which is y equals to a is to sine of k is pi. So we'll write pi, and x minus 1, that is the value of p, plus d, which is minus 1. Do you see that? So I get my first equation. To get the second equation, we'll look into the sine wave from some other angle, right? So we could see from this position also. If I look from this position, it is actually going downwards instead of going upwards. That means we could write this as minus sign. It is reflection on the x-axis. So we say, well, it is phase shift is 180 degrees or pi. So, but we could write this as a negative wave. So starting negative, we'll write minus 2 sine pi x. Since there is no phase shift for the wave which is reflected here in this case, so that becomes our second equation, correct? So this is for the one which is reflection on x-axis. Do you see that? So we got two different equations for the sine function. Let us do the same for cosine function. For cosine function, the wave starts with the maximum. The wave starting from the maximum close to axis is right there. Now it starts from 0.5 on the left side. Do you see that? It starts 0.5 to the left side. Now each division is 0.5 here. So we can say phase shift P is equals to minus 0.5. Correct? So that gives us the first equation for the cosine function, and that is y equals to a is 2 cos k is pi x. Minus and minus becomes plus, so you could write half or 0.5 and minus 1 for d, right? So that is the first equation. The second point which you could consider was the cosine wave starting from there, right? So this could be the second maximum. So that starts from 1.5. Do you get the idea? So we could also write this as y equals to 2 cos pi x minus 1.5 minus 1. In fact, you could give the third equation also starting from here, but this is negative cosine. Let me add that for you. Minus 2 cos k value is same, but in this case this wave has moved 0.5 to the right. You see that? So we have x minus 0.5 minus 1. This negative shows reflection. So you must have seen that you could actually write many equations for the same graph depending on what you choose as your starting point for the cycle, right? So for the last equation, the cycle wave which we have selected is this one, right? So starting from bottom to this. So that is the cycle for the last one. Sometimes you may be asked to write down domain and range of your cycle. So in this case, the cycle will be from 0.5 to 2.5. I hope this video gives you all the concepts which you have learned about periodic functions so far. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.